Hi everyone. So we are factoring trinomials. These have three terms, right? 1, 2, 3, three terms. That's why they're trinomials. And we have a couple ways of doing them. We can factor trinomials by the AC method. We talked about that last time, right? And one thing I should mention is that the AC method always works. And I think I brought that up. And what I mean by that is, right, that it always essentially gives you the answer, right? As long as you follow the AC method, it will factor the trinomial if it's factorable. And if it's not factorable, right, then the AC method will tell you that in the second step, right, where you're looking for two numbers that multiply to A times C and add to B. If there are no such numbers, then the AC method tells you that it's prime, that it's not factorable, right? So that's one way. The other way is, we talked about before that, is if A is 1, then you can take the shortcut. I'll call this the shortcut, and then you don't really need the AC method, although the AC method still works. It's just a little bit extra work, right? So now we're going to learn a third way to factor trinomials. And this way doesn't always work either. It only works in certain specific cases, right? And it's called perfect squares. So these are perfect square trinomials. And it's entirely possible that you've already seen some examples of perfect square trinomials, right, which you factored by using presumably the AC method, right? So the AC method will factor perfect square trinomials as well, but it's not necessary because there is a shortcut to doing perfect square trinomials. So, right, so here's the shortcut. And again, if it's not a perfect square trinomial, then I would go back and try the AC method, right? So when you factor a perfect square trinomial, it's a perfect square. In other words, it looks like this. It looks like A plus B, the whole thing squared, right? Which is just another way to write A plus B times A plus B. And I'm using capital letters because it has nothing to do with this A and this B. Right? So when you multiply this out, you get the trinomial. What you end up with is, right, so first, I'm just using FOIL here. First is A times A, which is A squared. And then the outside is A times B. The inside is B times A. And then the last is B times B, or B squared, right? So that's just the usual FOIL. And we can simplify this a little bit. First of all, B times A, right, is the same as A times B because multiplication is commutative. Right. And now we have some like terms, right? We have 1AB plus 1AB. When you add those up, you just get 2AB. And then we'll leave the B squared and the A squared alone. Right. And that's what you end up with when you multiply this out, right? When you multiply out A plus B squared, right? So we're going to think about this backwards. We're looking at the trinomial, the A squared plus 2AB plus B squared. And if we see this pattern here, we should be able to factor it as A plus B squared. Okay? So keep this in mind. This is what we're going to use over and over again, right? And there's another version of this. If you happen to get A squared minus 2AB plus B squared, right? So this sign here, if it changes from a plus to a minus, then you can factor that as a minus b squared. All right, and you can check that by just changing the sign here and multiplying that out. What you end up with is negative 2ab instead of positive 2ab. So it's not worth going through that all over again. But this is it, right? These are what you need to factor perfect square trinomials. So let's see how that works when you're doing homework, right? When you're in practice. Okay, so here's our first example. We want to factor 16x squared plus 88xy plus 121y squared. And so, yeah, I deliberately started with a very difficult one. This is not an easy one. But it's one that could come up in the homework, right? So let's see if we can factor this. So it doesn't say how to factor it. So this is in the usual form, right? ax squared plus bx plus c, although there's also a y squared here and a y. But we've seen that before, right? And so this tells me we can factor this by using the AC method. Right? Let's try it, right? So we know A is 16, B is 88, and C is 121. Right? So let's go through the AC method, right? First step of the AC method is to multiply A times C. So that's going to be 16 times 121. And I don't know about you, but I cannot do this in my head, and I need a calculator for that. And my calculator says 1,936, which is a really big number. I mean, relatively speaking, we don't usually see numbers that big here. Right? So now, in step 2, we need to find two numbers, right, that multiply to 1,936, right? So the product is 1,936. And the sum, when we add those two numbers, we get B, right? We get the middle number, which is 88. Okay, so what two numbers multiply to 1,936 and add to 88? Yeah, it's obvious, right? I'm joking. It's not obvious. At least not to me it is. If it is really obvious to you, then congratulations, because this is not easy for me, right? Certainly not obvious. So should we go through the list, right? Let's start with the product. Try to do this. Yeah, so the product is 1,936. So let's start with 1 times 1,936. Obviously, when you add those up, you get 1,937. So this will be the product. This will be the sum. And we know that this does not equal 88, so we know that's not it. Right? So the usual way is to just divide by 2 next. And when you divide by 2, you get 2 times 968. 968. And those 2 plus 968 is 970. Still not 88, right? And you can see this could take a while, right? So if we divide by 3, can we divide by 3? Actually, no, it doesn't divide evenly by 3, does it? So we can skip that one. Let's divide by 4. And when we divide by 4, we get 484. So 484 plus 4 is 488, which is not 88, so we have to keep going. So clearly we're not going to be able to divide by 5, or 6, or 7. Can we divide by 8? So I think it's 242 times 8. Yep. And when you add those, you get 250. Oops, sorry. 250 is the sum, still not 88. Right? So we know we cannot divide by 9. Now, how do I know that, right? Well, if you can't divide by 3, you're not going to be able to divide by 9, right? or any multiple of 3 for that matter. Right? So what about 10? Well, 10 would have to be divisible by 5, and we know it's not right. We tried 5, and that doesn't work either. So it's not going to be divisible by 9 or 10. How about 11? So that's a little less obvious. If we divide by 11, we get 176. Right. So 11 plus 176 is 187, right? Which is still not 88. So you can try 12. 13, is it divisible by 13? I don't believe so, but let's check on the calculator. Nope. 14, no. How about 15? No. 16, well, 16. Right. Yep, 16 is 121. Yep. So 16 times 121, you can check, is 1,936. Oops, that's supposed to be a 6. And 16 plus 121 is 137, which is not 88. Right. And again, it's looking pretty hopeless here, right? You can try dividing by 17. I don't think that works. Nope. 18's not going to work. 19's probably not going to work. Nope. 20's not going to work. 21, 22. Let's see. Yep, 22 times 88 is also 1936. Okay, and 22 plus 88 is 110. Still doesn't work, right? So you can try 23. I don't think that's going to work. Let me get a calculator here. Divided by 23 doesn't work. 24 doesn't work, right? Because you get a decimal, right? You don't get a whole number when you divide. So 26, 27, 28, none of those work. So I'm just skipping those. 29 doesn't work. 30 doesn't work. 31 doesn't work. 32 doesn't work. 33 doesn't work. Because it's divisible by 3, right? 34, 35, 36, 37, 38, 39, nope, 40, 41, 42, 43, and 44. Yeah, 44 works. So everything between 22 and 44 did not work. It's 44 times 44, and 44 plus 44 is 88. Okay, so it is factorable. It's not prime. We just had to go through a very long list here before we got to the one that works, and it does work. Right. Not pleasant. Okay, so let's continue with the AC method. So step 3 is to take the original 16x squared plus 88xy plus 121y squared and split up the middle term, the 88xy, into the sum of these two numbers. 44 plus 44 is 88, right? So 44xy plus 44xy is 88xy. All right. And now we have 4 terms. So the fourth and final step here is to factor by grouping. Remember how that works? We split this up and we factor the first 2 terms. 16 and 44 are divisible by 4. So we factor out a 4, right? And we get 4x. Oh, we can also factor out an x. Sorry about that. So 4x is the GCF from just the first 2 terms, right? Okay, so that's 4x plus 11y when you divide. And from the last 2 terms, well, 44 and 121, I think, are both divisible by 11. And they both have a y. So factor out the 11y. 44xy divided by 11y is just 4x. And 121 divided by 11 is 11. Y squared divided by y is y. So if we did this right, the 4x plus 11y should match. And we can factor that out. And what does it multiply? Well, it multiplies 4x plus 11y. And I think we're done, right? We factored this as 4x plus 11y times 4x plus 11y. Right. On the other hand, right, you don't write, w times w. You write w squared. So because these 2 factors are exactly the same, we don't want to leave it like this, right? We want to write it as a perfect square. We're taking 4x plus 11y, multiplying by itself, also squares it. So that's how we should write the answer. So yes, you might have seen something like this in the homework before where you end up with the same factor. I don't think we did one in these videos yet. I don't think we've come up with something like this yet. But so this is the first one, right? So remember when I talked about a shortcut? This is obviously not the shortcut. This is the AC method, right? So the AC method works, and it worked here. It worked for this example. It just took quite a long time, didn't it? Right. So maybe we should do the same problem just using the shortcut. So let's go down here and we'll do that. Okay, so here's the same problem, right? We want to factor 16x squared plus 88xy plus 121y squared. Right. And we did it by using the AC method, so we know what the answer is. But now this is the shortcut, and we're going to use what we saw earlier, a squared plus 2ab plus b squared. When you see this, it factors as a plus b squared. So what we have to do is recognize what is the a and what is the b here, right? And before we do that, I might want to remind you of the perfect squares. So I'm going to move this over a little bit. And let's talk about the perfect squares numerically. These are just the numbers, right? So if you multiply 1 times 1, you get 1, right? So 1 is a perfect square. Right? 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. Right? 16 is a perfect square. 25 is a perfect square. 36. 49. 64. 81. 10 times 10 is 100. 100 is a perfect square, right? And 11 times 11, 121. And if I can squeeze in one more here, 12 times 12 is 144, right? And they keep going. There's also 169, which is 13 times 13. And 196 is 14 times 14. And I guess I'll leave it at that. So yeah, these are good to know. Of course, you can always check these on the calculator, right? If you want to know if a number is a perfect square, like let's say you get a really big number, like 576, is that a perfect square? So on your calculator, you see this little square root button. If you take the square root of 576, you should get 24, which means 24 times 24 is 576. So it is a perfect square, right? If you want to check if 814 is a perfect square, take the square root of 814 on your calculator, and I get 28.5306, blah, blah, blah. So because this is not a whole number, because it has a decimal component to it, 814 is not a perfect square. All right. But just because they come up very often, and you're not going to see numbers like 576 or 814 very often, but you will see 36, 49, 81. So these are probably good to know. All right, let's get back to the problem now. We want to factor this, and so we recognize, look, 16, right? That's the a here. Well, it doesn't include the x. The a also should include the x here. 16 is a perfect square, right? It's 4 times 4. So I'm going to rewrite 16x squared here. In fact, I'm going to rewrite the whole thing as 4x times 4x. 4x times 4x is 16x squared, right? Let's leave the middle term for the moment here. The 88xy, we'll come back to that. Let's go on to the 121y squared. 121, way down here, is 11 times 11. So 11 squared, right, is 121. And then y squared is y squared. But remember, right, you can square the whole thing. This is the same thing as just 11 times y, the whole thing squared. So I did that all at once over here, but I just want to show you that you can do that separately and then all at once. So 11y times 11y is 121y squared. Okay, now let's go back to the middle term, right, that I said we were skipping for the moment. Now we have to come back to that. 88xy, right? So we know that capital A is 4x and capital B is 11y. So is this a perfect square? Is the middle term 2 times AB? So what's 2AB? Well, it's 2 times 4x times 11y. So let's multiply that out, right? We get 2 times 4 is 8. 8 times x is 8x times 11y. So 8 times 11 is 88, and x times y is xy. Perfect match, right? 88xy is the middle term. So the middle term is 2 times a times b. Now comes the factoring part, right? We're almost done. The factoring is this. It's just a plus b squared, where a is 4x and b is 11y. Right? That should be a y here. Right. And we're done. There's the answer. So compare that with using the AC method. And you tell me which way you think is easier. All right, so again, I'm not going to say that they're always this much easier or faster, but I think this one was considerably faster than using the AC method here. So while the AC method always works, it's not always the best way. It's not always the fastest way. Okay, so it is helpful to get used to these perfect squares when they come up, right? They don't always come up, right? Like I said, the perfect square method is a shortcut, but it doesn't always work. Right? It's just like, right, a is not always equal to 1, and so that shortcut also doesn't always work. So the only thing that works for certain is the AC method. But as the problem is, as we saw, is that the AC method might take quite a long time to figure out. And so it's sometimes helpful to have these little shortcuts here. All right, so let's try another one. Okay, so here's our second example. We want to factor m squared minus 12m plus 36. Right, and there's a lot of ways we can factor this. Notice that a is 1 here, so we could use that shortcut. We could also use the AC method, and it's probably not that bad here. Right? But the thing to notice is that 1, right, the coefficient 1 is 1 squared. It's a perfect square. Right? And 36, and again, I erased the list here, but 36, when you take the square root of that, you get 6. So 6 times 6 is 36. That's also a perfect square. So when you see the first term and the last term are perfect squares, this is a good indication that we can factor this as a perfect square trinomial. Right? In other words, that this fits the pattern a squared minus 2ab plus b squared, and we can factor that as a minus b squared. All we have to do is recognize what is a and b here, right? So a is just 1m, or m, and b is just 6. So if this works, this is just m minus 6 squared, and we're done. Okay. So see how easy that was? Hang on, though. There's one thing we forgot, and this is very important. We didn't check the middle term. Because if the middle term doesn't add up to the negative 2ab here, then it's not going to be right? Then we'd have to cross this out then. So let's check the middle term. Right, so what is this negative 2ab? Well, it's going to be negative 2 times a, but remember a is m, and b was 6. So negative 2 times 6 is negative 12, and then times m. But negative 12m is the middle term, right? Right? So it's a match. And that's how we know that this is correct here. So yeah, once you get used to this, it goes pretty quickly, right? So let's try one more. Okay, third example, we want to factor 49y squared minus 70y plus 25. Okay, so here a is not 1, right? Little a, I should say, is 49. Little b is negative 70, and little c is 25. Right? So we can't use the a equals 1 shortcut. We could use the AC method again, but that would require multiplying 49 times 25, and you get a pretty big number. You get 1,225. Okay, so yeah, we could use the AC method, but that could take a while. Instead, let's see if these are perfect squares here, right? So the 49 is certainly a perfect square, right? It's 7 times 7. And the 25 is, well, 5 times 5, right? So we can rewrite this as 7 squared times y squared minus 70y plus 5 squared, right? So this is just 7 times y, the whole thing squared, minus 70 times y, plus 5 squared. So writing it this way, this is in the form capital A squared minus 2ab plus b squared. Right? So we recognize a, that's what's in the parentheses here, is 7y, and the b is just 5. Okay? So once we recognize what is capital A and capital B, we know that this factors as a minus b squared. And in this case, it's going to be 7y minus 5 squared. But before you jump to conclusions and say that that has to be it, remember, it doesn't have to be yet. We have to check that the middle term here matches, that the negative 2ab really is negative 70y, right? And there's actually two ways of doing this. One way is, remember, the old-fashioned way to check this is to just multiply it out, right? Just use FOIL, right? It's 7y minus 5 times 7y minus 5, right? Yeah, be careful you don't just square this and this, right? It's not 49y squared plus 25. Don't make that mistake, right? You have to use FOIL here. Okay, so first 7y times 7y is 49y squared, right? And then the outside term, 7y times negative 5 is negative 35 times y. The inside term, negative 5 times 7y, is also negative 35 times y. And then negative 5 times negative 5 is positive 25. So when you add up the two middle terms here, negative 35y minus 35y, you get negative 70y. Oh, sorry, 25. Right? So 49y squared minus 70y plus 25, it's way up here, but that was the original question. So now we know that, right, we can put a box around this. Now we know that this is correct because we checked it. Right? So you can do that, or maybe a little bit faster to just multiply this out. What's negative 2ab? It's negative 2 times 7y times 5. So negative 2 times 7 is negative 14. Negative 14 times 5 is negative 70 times y. And that is the middle term here. And so that's all you needed to do to make sure that this is correct. Okay. All right, let's try another one. Okay, so we want to factor x squared plus 13x plus 36. All right, and I think I had the 36 up here, right? 36 is a perfect square. So we could rewrite this as x squared plus 13x plus 6 squared, right? So in this case, the a is x and the b is 6. So since this fits the form, right, this is, let me write the form again, a squared plus 2ab plus b squared. And this factors as a plus b squared. This should equal x plus 6 squared, right? Because the a is x and the b is 6. Okay, is that right? Well, let's check, right? Let's do the middle term here. So what's 2 times ab? So 2 times a, remember a is x and b is 6. So 2 times 6 is 12, and 12 times x is 12x. But that's a problem, right? Because that's not the middle term. That's not 13x. Right? Oops. 13x. So this did not work. This is not the right answer. Okay? Yeah, this is an issue. This is something you have to sometimes worry about. You can't assume that just because the first and last terms here are perfect squares, that it's a perfect square trinomial. Right? So this one's a little bit deceptive here. This was a tricky one. Okay, so what does that mean? Does that mean, well, then it's not factorable, then it's prime? Is this prime? Well, maybe, but we should check. We should factor by some other method. We could use the AC method, Or because a is 1, all we really need to do are look for two numbers, right? And they're both positive in this case, whose product is 36 and whose sum is 13. So what two numbers, what two numbers multiply to 36 and add to 13? Okay, so let's go through the list here. 1 times 36 is 36. 1 plus 36 is 37, which is not 13. You could do 2 times 18 is 36. 2 plus 18 is 20, which is not 13. So what if we divide by 3? 36 divided by 3 is 12. And 3 plus 12 is 15. Close, but it's not 13. Okay, so divide by 4. 36 divided by 4 is 9. 4 times 9 is 36. Now what's 4 plus 9? There we go, 13. We got it, right? So the two numbers here are 4 and 9, right? Which happen to be perfect squares. However, that's just a coincidence, right? They didn't have to be here. But that's how to factor, right? So we get x plus 4 times x plus 9. And because the 4 and 9 are not the same, this is not a perfect square trinomial. Okay, so we tried it by perfect squares, but because the 2ab here did not match the middle term, right, then we couldn't do it by perfect squares. Right, so we had to do it by, again, I took the shortcut, or the AC method would have given you the same answer here, right? So the answer here, when you factor x squared plus 13x plus 36, you should get x plus 4 times x plus 9, or x plus 9 times x plus 4. Order doesn't matter. It's a 4. Okay, so yeah, so you have to be careful because even when the first term and last term are perfect squares, that doesn't mean it factors as a perfect square. You have to check the middle term. All right, I think you can try one on your own now. Okay, so try p squared minus 6p plus 9. Yeah, they don't come much easier than this, right? Because 9 is just 3 times 3, 3 squared. So a is p, and b is 3. That helps to write that down, right? And we can do this, right? 2ab is 2 times p times 3, which is 6 times p. Okay, there should be, right, it's negative 6p, so it should be negative 2ab. But all that means is that when you factor this, right, you're going to factor it as a minus b squared rather than a plus b squared, right? So this should just be p minus 3 squared. Okay? Yep. And of course, you could have done this by just the usual AC method, or just what two numbers multiply to 9 and add to negative 6? Well, it's negative 3 and negative 3. Okay? So if you did it that way, you might have factored it as p minus 3 times p minus 3, right, which is correct. However, you should write it as a perfect square, right? Because, look, we don't write p times p, right? We write p squared. So we don't write p minus 3 times p minus 3. We write it as p minus 3, the quantity squared, right? Okay. I mean, look, not a big deal. If you do leave it like this, you'll get partial credit, of course, but you'll probably lose a point for not writing it as a perfect square, all right? So just keep that in mind. Yep. Try this one. Okay, 144d squared plus 24d plus 1. Okay, so the 144 is a perfect square. You take the square root and you get 12. So 12 squared is 144. This is 12 squared times d squared plus 24d plus 1. And 1 squared is 1, right? So 1 is also a perfect square. So 12 times d quantity squared plus 24 times d plus 1 squared, right? So what's in the parentheses? That's my a and b. A is 12 times d, and b is just 1. Okay, so before we factor this, let's check the middle term. If we multiply 2 times ab, I get 2 times 12d times 1. But that's just 24d, perfect match, right? So this factors as, well, a plus b squared, or in this case, 12d plus 1 squared. Okay, try another one. Okay, factor 4m squared minus 24m plus 36. Okay, so what do we remember about factoring? The first thing you should always look for is the GCF. Now, why didn't I even mention GCF at all? Because in most cases, in all the previous cases, the GCF has been 1. And when the GCF is 1, I just ignored it, right? You just move on. But here, the GCF is not 1, right? The GCF is 4. Right? All these numbers are divisible by 4. And so we should factor out the 4 as the GCF. Okay, kind of tricky, right? Okay, now what's left over is a trinomial, right? It's m squared minus 6m plus 9, and that looks awfully familiar, right? It's one that I think we've done before. Maybe this was a plus and it was an x instead of an m, but it's definitely a perfect square trinomial because 9 is 3 squared, right? So this should factor as m minus 3 squared. Okay, and that's it. We're done. Right? I mean, I didn't check the 2ab, but we did that earlier, right? Negative 2ab is negative 2 times m times 3, which is negative 6m, which is a perfect match, right? Right, you're not comparing it with the negative 24m, the original, right? We took care of that by factoring out the 4 first, okay? So it is a match here, this negative 6m and negative 6m, right? Because we're just trying to factor this, right? I mean, originally we're trying to factor this, but after factoring out the 4, we've made it a little bit easier, right? Okay. Now, I recognize that some of you probably didn't bother factoring out the GCF. Okay. The point is you don't have to, right? In this example, if you don't factor out the GCF, then you can factor it the following way. You can say, well, look, 4 is a perfect square. It's just 2 times 2. So my a is 2m, right? We'll look at the 24. And 36 is just 6 times 6. So b is 6, right? So a is 2m and b is 6. So let's check the middle term. Is it negative 2ab is negative 2 times 2m times 6. So negative 2 times 2 is negative 4. And negative 4 times 6 is negative 24. And that is a perfect match, right? So because of that, we can factor this as a minus b squared. In this case, a is 2m and b is 6. So we get 2m minus 6 squared. Okay, so if you got that, well, I mean, look, it's correct, but the problem is it's not really correct. It's not the answer, right? We know what the answer is, and that does not look like the answer. So this is factored, but it's not factored completely. So if you left your answer like this, you will get partial credit because it is factored, but it's only partially factored. But you see the issue, right? We didn't factor out the 4. Well, here we have 2m minus 6. The 2 and the 6 have a common factor of 2, right? They're both divisible by 2. So what we need to do is factor out a 2 here. And then you might wonder, wait a minute, I thought it's supposed to be a 4, not a 2. Well, look at what we have here. We have 2 times m minus 3 squared. So what are we squaring? The m minus 3, but we're also squaring the 2 here, right? So this is going to be 2 squared times m minus 3 squared. And 2 squared, 2 times 2 is 4. So now we have the same answer, right? 4 times m minus 3 squared. Right, so now it's factored completely. And you won't lose any points as long as you factor it completely. Okay. So that's the issue with not factoring out the GCF. If you didn't factor out the 4, okay, you can do it the usual way, as we did it here. The problem is too many students tend to leave the answer like this, and then they lose points for not factoring out the GCF, which in this case is the 2, and then the 2 will get squared here. So yeah, a little bit confusing doing it this way, right? But that's why you should always factor out the GCF. Right? If you factored out the 4 first, then you're making it easier on yourself, right? The rest of it should be factored usually a little bit easier than the way we did it here. Okay? Makes sense. And again, if you're worried about the 4 instead of the 2, keep in mind that, right, we could have written this as 2m minus 6 times 2m minus 6. And when you do that, you factor out a 2 from the first factor, and you factor out a 2 from the second factor. So you're factoring out 2 times 2, which is 4. So either way you do it, you should get this as your answer, 4 times m minus 3 squared. Okay, so yeah, a little bit of a tricky one if you forgot the GCF, right? And even if you forgot the GCF, you can still get the correct answer here. It just takes a little bit longer. Factor out the GCF first, and it's pretty short. You get the answer pretty quickly. Okay? Okay. Try this one. You want to factor 25r squared minus 30r times s plus 9s squared. Okay, so the fastest way to do this is to recognize that this is a perfect square. And the 9 is 3 times 3. 9 is a perfect square. So my a is just 5 times r. And my b is 3 times s. Okay, so we get minus 2ab, because it is a negative sign here, is negative 2 times 5r times 3s. And when you multiply that out, you do get negative 30rs. Perfect match, right? So that just tells me I can factor this as 5r minus 3s squared. And we're done. All right, try this one. All right, 16x squared plus 30x plus 9. Okay, so you probably recognized 16 as 4 squared. Perfectly fine. And 9 is 3 times 3, so that's 3 squared. So my a should be 4x, and my b should be 3 again. Okay, so let's check 2ab. This is a positive this time. 2 times 4x times 3 is 8x times 3. 8 times 3 is 24x. Oops, that's a problem because the middle term here is not 24x. These are not a match. Okay, so yeah, this is not a perfect square. Okay, well, if it's not a perfect square, don't assume that it's prime. It may be, it may not be prime. So unfortunately, we have to go back and now use the AC method. As unpleasant as that is, unfortunately, we don't have a choice here, right? Because a is not 1. Right? So a, my little a here, is 16, little b is 30, and little c is 9. So a times c, 16 times 9, I think is 144. And so we need two numbers that whose product is 144, right? So this is the product here. And the sum has to be 30, right? So when you add the two numbers, we're looking for 30. Right. Now the 144 is a perfect square, and the one we tried already was, right, 12 times 12, but 12 plus 12 is 24, not 30. So that's why the perfect square didn't work. Right. So what other two numbers multiply to 144? Oops, sorry. Let's do 1 times 144. The sum is 145, not even close, right? So divide by 2, and I think you're going to get 72 times 2 is 144, right? And 2 plus 72 is 74, right, which is not 30. So let's move on. If we divide by 3, 144 divided by 3 is 48. Yep, that's not going to work either because that gives you 51 when you add 3 plus 48, right? If you divide by 4, you get 36. 36 plus 4 is 40. Not 30, so not what we're looking for. If we divide by 5, I think we just get a decimal, 28.8. So we can skip 5. Can we divide by 6? Yep. 6 times 24 is 144, right? And 6 plus 24 is indeed 30. So we have our match, right? So the two numbers we're going to split this up as is 6 and 24. Okay. So 16x squared plus 30x plus 9. Remember, we split this up as 6x plus 24x, right? Because that does equal 30x. Okay, now we factor by grouping, so we split this up. We factor from the first two terms. I think we can factor out a 2 and an x, so that leaves us with 8x plus 3. And from the last two terms, the 24 and the 9, we can factor out a 3, I think. That's it. And then when we divide, we get 8x plus 3. So the 8x plus 3 is our common factor. And that multiplies the, oops, sorry. the 2x plus the 3. And that's it. Of course, if you split this up as 24x plus 6x, you probably got the 2x plus 3 first, and then the 8x plus 3. That's not a problem. Same answer, just written backwards or written in the opposite order. Right. So there you go, right? This looked like it was going to be a perfect square because the first and the last terms were perfect squares. However, because the middle term, the 30x, is not the 2ab, it was not a perfect square trinomial, and that forced us to use the AC method, which again worked in this case, and it's not prime. Okay. All right. I guess I'll let you try one more, and then we'll move on. Okay. 4x squared plus 9x minus 9. Right, so again, the first term is a perfect square. And the 9 is a perfect square. However, the problem is that it shouldn't be a negative 9, right? This should be a plus. Remember, the two forms for perfect squares are a squared plus 2ab plus b squared. The other, right, so that factors as a plus b squared. The other one is a squared minus 2ab plus b squared, and that factors as a minus b squared. But for both of these, that last term always has to be a plus, not a minus, not a negative. Okay, so already we know that this is not a perfect square. Right, and there's something else that tells us that as well. The middle term, right, is 9x. Remember, the middle term has to be 2ab. So that too tells us that the middle term, right, the middle term has to be even. Right? Has to have an even number in order for this to be a perfect square trinomial. And 9 is an odd number. 9 is not even. So that's another way to tell that this was not a perfect square. Okay? So again, a little tricky there. If you tried to factor it as a perfect square, it's not going to work. So that leaves us with the AC method again. So A is 4, B is 9, and C is negative 9. And so A times C, 4 times negative 9 is negative 36. So what two numbers multiply to negative 36 and add to 9? So the bigger number should be positive, right? So it's not negative 1 and 36, it's 35. Negative 2 times 18 is negative 36. That adds to 16. And then if you divide by negative 3, I think we get 12. And negative 3 plus 12 is 9. So there's our match. So you split this up. 4x squared minus 3x plus 12x minus 9. Of course, you can change the order. If you want to do the positive 12 first, that's fine. I'll do it this way. Right? So you factor from the first two terms, the GCF is just the x, leaving you with 4x minus 3. From the last two terms, you can factor out a 3, leaving you with 4x minus 3. So now just factor out the 4x minus 3, and that multiplies x plus 3. Right? Or if you prefer, you can do x plus 3 first times 4x minus 3. Okay, so another example of the AC method, just to show you that the perfect square trinomials here, well, they're great when they work. When they don't work, you're stuck with the AC method. Right? Okay. So that should do it for perfect square trinomials. And I know this wasn't a perfect square trinomial. Neither was this one. So, all right, so maybe I'll give you one more. Okay, last one. We want to factor 9w squared minus 60wy plus 100y squared as a perfect square trinomial. So I promise you this will be a perfect square trinomial. So no AC method is necessary. Right. Although the AC method does work here, it might take a while, right? So the quickest way is to recognize that this is 3 times w squared minus, and then this will be 2ab. We'll get to that in a second. And then 100 is just 10 times 10. So this is 10y squared. So my a is 3w. My b is 10y. And because it's a negative, we'll do negative 2ab. So negative 2 times 3 is negative 6. Negative 6 times 10 is negative 60. And this is a perfect match, right? So we know this is a perfect square trinomial. And all you have to do now is to factor it as, right, a minus b squared. Why minus? Because the middle term is a minus, is a negative, right? So a was 3w and b was 10y. So this factors as 3w minus 10y, the whole thing squared. And we're done. Right? So, yep, so that's the idea of perfect square trinomials. And of course, you just have to remember the pattern. A squared plus 2ab plus b squared, which is a plus b squared. And then a squared minus 2ab plus b squared. That's just a minus b squared. So really good if you know those. And so before we go, I just want to summarize what we've been doing past couple of videos. These are trinomials. Right? So anything of the form ax, and it doesn't have to be an x, right? It could be a y or a w or a z or any letter. So ax squared plus bx plus c. These are trinomials, right? And there's 3 ways of doing this. The first way we learned is if a is 1, and that's a shortcut that doesn't always work. The second way we learned is the AC method, which always works. And be careful. By that, I don't mean it's not prime, right? It could be prime, but the AC method will tell you that. If you go through the whole list and you don't see a match, then you know it's prime, right? But what I mean by always works is it'll always either factor it completely. Well, if it'll either factor it or it'll show you that it's prime. And then the third and final way are the perfect square trinomials. Okay. And, right, the only one you have to know for sure, of course, is the AC method, because that will get you the answer every time. Right? You could ignore the perfect squares. You can ignore the a equals 1 and still be okay. Just realize that, you know, if you only work with the AC method, it's not always the fastest or best way of doing it. Right? So perfect square trinomials, when it works, and again, it doesn't always work, it is a nice shortcut. And of course, when a is 1, that's also a nice shortcut when it works. It doesn't always work, right? It doesn't always apply, I should say. Right? So not right. When a is not 1, you can't use that shortcut, right? And when a and c are not perfect squares or are reducible to perfect squares, then you can't use the perfect square trinomial shortcut. So ideally, you should know all 3 of these methods. And once you get used to all 3, you can factor any trinomial of this form. Okay, so that's what happens when you have 3 3 terms. I hope that helps, and best of luck.